Welcome, everybody. This is episode 157 of the Minnesota Outdoor Skills and Stewardship Series. We're really great to have you here with us today. We're going to be talking about barotrauma and some considerations as we're angling for these fish with a big focus on crappies and some of the new and emerging research that DNR staff have been working on in our fisheries division and section. We're really excited to have with us a couple of those experts. Dave Weitzel will be talking and walking through the program with us today. And we also have Dr. Isaiah Polo, who's our fish health supervisor, with us to help answer some of the tough questions. So get those ready and put them in the Q&A. I'll hand it over to you to Dave. Thanks for joining us. Really fun to talk about this. We still had one last reprieve for us, but we'll be out fishing in the spring here really soon, I hope. So thanks for joining us.
Yeah, no, thanks for having me. Yeah, it definitely looks like winter up here in Grand Rapids again, but I think it'll be relatively short-lived, and yeah, it won't be long. And these crappies will be moving out of some of the deeper habitats, and we'll be catching them in the near shore areas. So definitely looking forward to that.
Yeah.
Well, just kind of a quick introduction to folks that might not have had a chance to meet me in the past. I'm Dave Weitzel. I'm the Assistant Regional Fisheries Manager up here in Grand Rapids for the Northeast region. But as part of my job, I've been very privileged to have had the opportunity to be part of the DNR's Panfish technical team since about 2015. So this is kind of our internal team of technical experts that do a lot of research and fisheries management that's directly related to panfish. And one of the things that we've been interested in lately is this idea of barotrauma, which affects fish that are caught in deep water. A little bit of background, this topic really came to us by working through our citizens work group. Our technical teams also have citizens work groups, which are made up of folks from all around the state that enjoy fishing. We've got resort owners, fishing guides, lakeshore owners, everyday anglers, and we meet a few times a year, and they kind of guide us on topics of interest where they'd like to see a little bit more focus in terms of some of the research and some of the work that we're doing within the section of fisheries. And barotrauma is definitely something that's been interesting to them. They ask us to take a little more in-depth look, and we've been able to do that. So I'm hoping to present some of that information to you today. So what is barotrauma? Barotrauma refers to basically injuries or trauma that fish may experience when they're taken from deep water into shallower water. And basically what's happening is that these fish, when they're at depth, have to deal with the weight of the water that's above them, and that creates what's known as barotraumic pressure. When we bring those fish to a shallower depth, that pressure is actually reduced, and that allows any gases that are within that fish to expand. So the rapid expansion of these gases can cause physical damage to the fish, which can certainly cause harm to the fish, or in some cases even cause mortality. It can essentially kill the fish. Some fish are more susceptible to barotrauma than other fish. Fish like trout, salmon, and pike actually have a duct connecting their swim bladder to their stomach, which allows them to release some of this air as it expands in their swim bladder. In essence,
hey,
they can, yep.
And jump in quick, your presentation just disappeared.
Oh. Let's try this again.
But before you get too far ahead there, see if we can.
No, I appreciate that.
Now we got a screenshot, so. We have lots of these fun fish work groups that meet too. I know we got one over in Hutchinson. I'm sure they're all over the state, but it's a good way for people out there to get involved and give us your opinions too. So if anybody in the audience today is interested in joining one of these technical work groups or something to get more involved in some of the fisheries research we do, please reach out to Dave or myself and we can do that.
Yeah, absolutely. It's been a little bit of a change in how we've done business over the years, where, traditionally a lot of this kind of work was done at the individual area level, which generally works pretty good. But sometimes it's really important to take a statewide perspective on things, and that's where these work groups have been awesome.
We can see your slides now, Dave. Yeah, but if we get it to run slides, there we go. Looking good now.
All right. Okay, it seems to be advancing all right, and I think we've fixed the technical glitch. I apologize for that. So as I was saying, some fish are able to deal with this rapid expansion of gas because they have this duct that connects their swim bladder essentially to their stomach and then through their throat to the mouth. But other fish don't have this. So fish like crappie, walleye, perch, or bass really have to regulate that gas expansion much more slowly through their gills. And this means when we bring them up from deep water rapidly, they can't get rid of that gas fast enough. And it can often result in a bloating appearance when these fish are brought to the surface. In the case of this photo, you can see the basically capillaries in the mouth of a walleye that have burst. You can actually see those gas bubbles forming. So in the case of this fish, we're seeing some damage to some blood vessels. So there's several different physical effects that we may see. First off, when we try to release that fish, it's fighting against this expanded gas. The fish is more buoyant, so it might not be able to swim down. Or if it does swim down, it might be disoriented. It might not know which way is up. It might have trouble returning to depth and staying there. Oftentimes, we'll see things like bulging eyes, like we see in the photograph. We might see that bleeding in the gills. The swim bladder might actually expand to the point where it forces the stomach through the throat of the fish and into the mouth. Internally, there can be a lot of damage. There may be blood clots. We might see ruptures or other damage. Certainly, there can be hemorrhaging or bleeding inside the fish's body. And in some cases, it can be severe to the point where the fish will actually die from it. And this mortality may occur immediately when we catch that fish, or it may occur sometime later after that fish has been returned to the water. Even if a fish appears fine when we release it, we've learned that delayed mortality may occur due to swim bladder damage or other physical injuries that are internal, so injuries that we can't necessarily see. We also know that the barotrauma effects really vary based on depth. And the deeper we go, the more those gases are going to expand when we bring that fish up to the surface, so the more damage generally occurs. There's been a fair amount of barotrauma work that's been done in the past, but most of these studies have really occurred during the open water period. And they found that mortality generally starts to become a concern when depths exceed approximately 30 feet. So concerns are generally higher when we start talking about angling in some of our larger, deeper water bodies. Probably not a big concern in a small, shallow lake. So as I mentioned, we have this panfish technical team that's partnered up with a citizens work group. And our citizens work group had concerns about release of crappies from deep water, especially during the fall and winter. For those of you that might like to angle for crappie, you might have come to realize that these fish go through a fairly predictable migration pattern every fall. After the lake turns over in mid-September, these fish oftentimes head toward the deepest part of the lake, and they'll either suspend or orient themselves near the bottom. And they'll spend much of the fall and oftentimes the first half of the winter out in these deep basins. It's really nice because if you have a lake map, it's pretty easy to find these fish. But the downside is if we're going to go out and angle for them, we have to be aware of this potential for barotrauma. Fewer of these studies have been done under the ice, primarily because of the difficulties of working in a frozen lake environment. So this project was initially proposed as a pilot study back in 2022. And mostly we just wanted to go out on a few lakes and see if we could catch enough fish to be meaningful. Could we place nets through the ice without them freezing in? Was it logistically possible to do this type of work in the wintertime? And if so, we wanted to really look at the number of dead fish versus the number of fish that were alive. In 2022, we were able to do some evaluations on 3 different lakes. We found that as long as we picked days that had the right kind of weather, it was a very doable project. So we expanded it to a full-blown study after things went surprisingly well. So this past winter, the winter of 2023, we went out on some additional lakes and collected some additional information. As far as the methods that we used, the fish were caught by angling. In some cases, we invited local sportsmen to come out. Sportsmen and sportswomen came out and helped us actually do the angling and catch these fish. The fish were caught at various depths. When we'd catch a fish, we'd give it a real quick physical examination and give it a general barotrauma rating, anywhere from 1 to 3. If there were no signs of issues, the fish was rated as a 1. If we saw that bloating or we saw bulging eyes, it was assigned a 3. And then we tried to release those fish as quickly as possible, either into a net pen or just immediately release it directly back into the lake, depending on what type of evaluation we were doing. In the case of the net pens, they were set in deep water. The pens were 45 feet long, essentially, so that we could set it, the pen, and when it would go from the surface all the way to the lake bed. So when we released the fish into the pen, that fish could swim back to the depth of its choosing. And we held the fish in the pens for between 24 and 48 hours, after which we lifted the pens and examined the fish. In a separate trial, we immediately released the fish, and then actually used forward-facing sonar to track those fish for several minutes to see how they reacted upon immediately being released. As far as our results went, when we looked at our fish that were caught in shallower water, these fish were caught at an average depth of 21 feet. We found that out of 50 fish, most of them showed no signs of barotrauma, although 18 fish did show mild signs of barotrauma. When we lifted those nets, we found that none of the fish had died. 48 fish had fully recovered, and then there were 2 fish that we kind of jokingly called zombies that hadn't fully recovered, but they weren't dead yet. It's likely that those fish weren't going to make a full recovery, but it was just too early to tell for sure. When we looked at a little bit deeper water, we saw that the signs of barotrauma started to increase a little bit. So at an average depth of 24 feet, we found that most fish showed some signs of mild barotrauma. And when we lifted that pen, we found that 4 fish had died, 46 had fully recovered, and then there was 1 fish that was still alive but not fully recovered. So even though a lot of these fish at 24 feet showed some signs of barotrauma, the majority of them appeared like they could recover. That was good news. But our deepest net started to look quite a bit different. These fish were caught at an average depth of 32 feet, and we found that the majority of these fish, really all of the fish, showed signs of barotrauma. In most cases, it appeared to be mild, although 5 fish did have severe barotrauma. And when we lifted that pen, we found that only 22 of those fish had fully recovered. 16 fish were dead, and the rest were still alive, but were showing signs of real trouble where those fish might not be able to recover. So a quick summary from the net pens, clearly shows that the deeper we went, the fewer fish recovered and the more fish succumbed to barotrauma, at least in these net pens. But we did have the question, what effect does the pen itself have? This is, kind of an artificial circumstance where we're holding these fish in a pen with other fish. They can't necessarily go where they want to go. So we had kind of a novel idea of trying to track some fish using forward-facing sonar. So basically, in this study, we caught the fish out of deep water. We had 2 sonar systems set up. Each could point at the hole where that fish was released. And then we tried to track that fish as long as possible. And the results were very interesting. We found that most fish, upon release, actually were able to swim down to the depth at which they were caught and could remain there for a few minutes. But after several minutes, several of these fish ended up floating back to the surface, and a few of them sunk directly to the bottom. We were able to go out the next day and use an underwater drone to visibly look for these fish. And what we found is that 12 fish were found floating right underneath the ice surface that had died out of 43 fish. So again, when we look at the numbers from deep water, these numbers were pretty similar to what we saw in the net pens, which suggests that whether we're looking at pen-held fish or immediately released fish, we're seeing similar levels of mortality associated with barotrauma. We also had the opportunity to take the fish from the pens and essentially take a look for internal damage using necropsy methods. So some of the living fish were examined, some of the dead fish were examined, and what we found is that some fish that had quite a bit of external signs of trauma actually had very limited internal damage. Ultimately those fish might be able to recover. Meanwhile, several fish that we considered recovered had significant internal damage, which very likely could lead to a future infection. So it's very likely that when we release fish from deep water, even though they seem to swim away and look just fine, some number of those fish are likely to succumb to delayed mortality at some point in the near future. This photo shows a damaged swim bladder, and you can see the fluid that's built up within that swim bladder and the blood in the fluid. That's not supposed to be there. It's likely that that fish would develop an infection. So this information's been very useful, and it's helped us develop some considerations for anglers. And the first bit of messaging that we want to share with anglers is that barotrauma isn't new, but this certainly confirms that it's a real event that's happening out there. Anglers have known this for a long time, that if you go out and catch fish out of deep water, that they're not going to swim down real well, and they may show physical signs of damage. And this is very similar to what we see with divers diving in deep water that might experience what a lot of people refer to as the bends. Our data suggests that barotrauma becomes severe somewhere between 24 and 30 feet. And that's very similar to findings from open water studies. We know that some fish will float but eventually recover, but we also know that some fish that swim down ultimately die. So delayed mortality is likely in some of the fish. And the other thing that we're really trying to do is use this as an educational opportunity. Our intention isn't to go out and say that people can't go out and enjoy a day of fishing in deep water. We just want them to have good information so that they can make sound decisions and practice good ethical angling when they're out there enjoying the sport. So what can anglers do? Well, there's several things that you can do as an angler. First off, just realize that barotrauma can impact fish survival. So think about it a little bit when you're enjoying that day on the water. You might want to consider reducing the amount of time you spend fishing in deeper water. Or if you're fishing in water deeper than 25 feet, you might focus on harvest that day instead of catch and release. I know, before I had the opportunity to do this barotrauma work, I might go out and catch 50 crappies out of 30 feet of water when they were biting really well and release 40 of them, thinking that, hey, they swam away, they're going to be just fine. But knowing what I know now, personally, when I go out and enjoy deep water fishing, I'll catch my 10 crappies, have a nice fish fry, but then I'm going to go spend the rest of my day catching bluegill up in shallower water where barotrauma isn't a concern. So that's kind of the presentation. With that, we'd certainly like to entertain any questions that folks have. I guess we'll turn it over to questions.
Thanks, Dave. Really great information. It's really exciting to see the research that folks are doing in the department, and especially in fisheries, and how that impacts what we know about fish, and how hopefully can inform those of us that are anglers on what we can do. I really liked your suggestion about moving on to like target sunnies in the shallow water. It's a really great idea. We did have a couple of questions. And folks, if you have additional questions, we have lots of time today to do that. So please put them in the Q&A and we'll get to them. Chris was wondering, and you kind of touched on this, but do you think there's any issues with using the net pens and not allowing the fish to utilize more of the horizontal plane of the water column to get back down to depth?
Yeah, that's a great question. We actually took a fairly in-depth look at that this past winter. And to try to evaluate that, we actually set up 2 nets on the same lake, set at the same depth. And the first net, we just released the fish directly into the net, kind of like we'd done the previous winter. With the second net, we rigged up what we called the descending device. Essentially, it was a lead weight that we could attach to the fish's mouth with a quick release mechanism. And we'd use a line to send that fish down to its capture depth. So we were immediately getting that fish back down to its capture depth and then releasing this descending device. Interestingly enough, what we found is initially those fish looked like they were going to do really well. They maintained their depth, but much like the forward-facing sonar, what we found after several minutes, those fish started to return to the surface. So in the end, we couldn't tell the difference between the descending device pen, the non-descending device pen, or the forward-facing sonar. It seemed like every one of those methods was kind of coming up with the same answer. So that led us to conclude that the net itself probably wasn't causing additional harm to the fish.
Okay. Yeah, you covered all the bases. That's great. Someone had asked about participating in some of the technical teams, and Benji actually put that in the chat too. So if folks are interested in learning more about the fisheries technical teams, check that link out, and there's information on our website. So thanks. Let's see here. Mary asked, does it make a difference if you pull a fish very slowly out of deep water?
That's a great question. I know when I was learning to fish, folks would give me that advice that if I reeled it in slowly over a longer period of time, that would give the fish a chance to adjust to those pressure changes. But unfortunately, with these fish that don't have that physical duct, for those gases to work their way out of the gills, it literally takes hours. So even reeling a fish in really slowly with something like a crappie or a walleye, it turns out that really doesn't benefit the fish. So the short answer is unfortunately not.
Yeah, and add on to that we're not just dealing with gases in the fish's air bladder, we're also dealing with gases in the fish's blood and in their tissues. So it's really difficult for a fish to equilibrate, and it can take a long time. So some of the really good research studies looking at marine fish have shown that it can take up to 14 hours for a fish to be able to essentially equilibrate to a new depth. So it's a long time, and unless you're going to sit there reeling up for 14 hours, you're really unlikely to change the outcome.
Yeah,
okay.
and with the case of our pens, when we retrieved those, we didn't want to induce additional barotrauma when we recovered the fish. So we were lifting that net pen over several hours, but even with that slow ascension, we were still seeing additional barotrauma. So it would take many, many hours.
Yeah, interesting. And Corey kind of asked a similar question, but I guess a new take on that is, did you do any variation on how quickly you brought fish in during the research?
No, generally those fish were, brought up as quickly as the angler chose to bring them up. So whatever was typical for that individual angler is how fast they were brought in.
Okay, we have a couple of folks that are interested in ocean fishing, particularly Alaska and halibut, but I've watched the videos after going down to Florida about some of those fishing out of depths and reefs and stuff. Are they affected in a similar way, ocean fish?
Yeah, absolutely. So most of the research on barotrauma has actually been done in marine systems, and in those systems, we're talking about depths that are a lot more. 30 feet is kind of this interesting place where you have basically 1 atmosphere of pressure, and so you get a doubling effect on like the size of basically what the air bladder wants to be. So with those fish that are living a lot deeper, you can imagine that those pressures on their internal organs are going to be a lot greater, and also the impacts from basically expansion of gases in their blood are going to be very great too. Some marine fish do have like the capability of dealing with higher pressures though, since they do kind of live in more of that kind of pelagic zone, and so they do have they are adapted to be able to use more of that space. But yeah, you'd see very similar effects. And a lot of the same disease signs, but in shallower systems, it seems like the fish may actually be a little bit more sensitive to smaller changes in depth.
And so, someone was saying that they fished halibut in 135 feet, and they did release some of the smaller ones, but they could have been impacted, it sounds like, potentially. I mean, I don't know how much you know about halibut, actually, but...
Yeah, I mean, but a halibut is a huge fish. It's definitely one that it lives on the bottom. It spends most of its time down there, but it does have an air bladder, and it also has the need to swim up to to catch fish, prey fish. So it has some ability to survive changes to its depth. It's adapted to do that. I'm not sure if anyone's done any survival studies on halibut, but with other fish like goldeye, it's actually you have to use a descending device if you're catching goldeye, where you're in a place where it's no take. That may not be that beneficial. We're finding with these kind of shallower living species like crappie, we didn't see any real benefit in using the descending device, either from like looking at survival rate or looking at their disease signs internally. So yeah, there's definitely some big differences between marine and shallow water fish.
But I know we had one of our colleagues on about a year ago talking about trout fishing in Lake Superior, in particular lake trout. And even though they have that tube that I think you're talking about, right? But they still can have issues if you're fishing them out of deep water, 200 feet or whatever, right?
Yep.
Oh, absolutely. Yeah, so lake trout, they are physostomous fish, so they do have the ability to burp, basically burp air out into their alimentary canal from their digestive system. But if they're being pulled up from depth pretty quickly, it's still hard for them to make the adjustments they need to make. Plus, they also have a lot of dissolved gases in their bloodstream. So one of the interesting things they were seeing with those fish, and it actually is similar to what we're seeing with the crappies, is that there can be kidney damage. So one of the pictures there we were showing was of this fluid building up in the air bladder, and that can be a sign of kidney failure or heart failure, either of which can occur from basically gases expanding in the bloodstream itself and then causing physical damage to those organs, or by the air bladder expanding so much that it can crush an organ. So that happens more with the salmonids. What we're seeing in the crappies looks more kind of like the damage caused by gases coming out of solution in their bloodstream.
Okay, thanks. Ken asked what about muskies? Do we have any research on that or know how they're affected by, because sometimes of the year they're in deep water too, especially in the fall.
Yeah, and I think there probably hasn't been a lot of specific data collected on muskie, just because it's hard to get a good sample size out of deep water. But physically they're built a lot like a northern pike. And so I'd put them kind of more in the realm of a lake trout, where they can probably deal with gas expansion a little bit better than something like a walleye or a crappie. But in deep enough water, they're still going to have the same issues that any other fish does.
Okay.
Yeah, well, they've definitely been studied more in the case of like turbine issues. So like if you when fish are passing through turbines, they'll experience similar pressure changes. So there's been some good Canadian studies that have looked at I think both muskies and northern pike, but I think they were actually looking at they were looking at both species, but they did see similar barotrauma effects. So they are still susceptible to barotrauma. But yeah, they definitely are more kind of that pelagic predator where they probably have some evolutionary changes that make them, capable of living in that area and be effective at catching prey, moving through depths. But yeah, they certainly do have issues with barotrauma as well.
Okay. Chris, I think we kind of touched on this, but the weighted descent that you did with the second study, was that a rapid drop back to the catch depth, and could that create more issues with trauma?
Yeah, it was a rapid descent back to their catch depth. I don't know, Isaiah, do you think that could be something that would contribute to more trauma?
Yeah, so actually repressurization damage hasn't been investigated very much in the literature. I don't think I've seen any published papers on repressurizing fish. But the number one treatment for the bends in humans is to repressurize. And the reason why is because you're trying to reduce the amount of gases that are coming out of solution and causing extra damage. So if you think about it this way, is that every now and then there's a bubble popping out somewhere in a tissue or a blood vessel that can lead to severe and catastrophic damage. So getting them down to depth as soon as possible is the best case scenario. It's true that you could potentially have some issues with, as you're putting them back down to depth, that you could be causing some strain on say, the air bladder that has expanded as far as it possibly can, and now you're putting it back down to pressure. And so maybe you could have some issues with that, but by and large, getting them back down to depth is going to be the very best thing that you can do to reduce the amount of internal damage.
Okay. Jonathan had a really good question about our results and the delayed mortality that we have in catch and release, especially with these deeper water fish, and is that factored into harvest regulations and planning? And if not, how do you think we should do that, or can it be done?
Yep, that's an excellent question. Up to this point, it really hasn't been considered in regulation planning. But keep in mind, the majority of lakes across Minnesota, especially for crappie, are regulated with the statewide 10 fish bag limit. And for the most part, statewide limits are pretty effective at limiting harvest as a first line of defense. But sometimes there's other fisheries goals that we're trying to reach. Like maybe we want to reduce mortality to increase average size of crappie. That's where this kind of data is going to be extremely useful, because we're trying to better tailor our special regulations so that they're only applied in environments where we're most likely to see the desired result. We don't know enough about crappie yet to quite make those prescriptive uses or regulations, but that's where we're hoping that this study can help kind of steer us in the right direction. And we might indeed learn that crappie regulations work best on shallower waters where barotrauma isn't an issue. That's yet to be determined. This study is actually in parallel with kind of a big crappie life history study that we're trying to do across the state of Minnesota. But those two components together, our hope is that that'll really help us fine tune the potential for future crappie regulations where there's a social desire to do kind of more of a crappie, a quality crappie style of management.
Yeah, that's really good to hear, because I shared with you is a very specific example that I have on the lake that I fish a lot in the Alexandria area. And 2 summers ago, or a year and a half ago, lots of 8-inch crappies. It was wonderful. You could easily go out and catch a lot of them, although not big enough in my book to eat, right? So I was so excited thinking next year, last summer, they were going to be big enough. There'd be plenty of them. But I do know there's some folks that definitely do a lot of ice fishing in the winter and probably may have kept some of those because they're approaching 9-10 inches last winter. But I also wonder, after talking to you, about how many of them might have been caught and released and then perished. And because last summer I couldn't find an 8-inch fish to save, or a 9 or 10-inch fish to save my life, fishing in all the same spots with all the same techniques. So, there's a lot of other reasons, of course, that population that year, that age group might have disappeared in the system. But yeah, interesting to think about what some of these impacts might be having on our populations. John had a question about these physostomic fish being better suited to be able to be caught at depth. But you touched on how we should, Azalea, you did a good job, I think, describing how we should still be worried about some of the blood and fluids in those species. But with these pelagic fish that have these designs, is there any talk on conducted research on physostomes in Minnesota that kind of will get into some of that?
I don't know of any.
Okay.
Yeah, I mean, there's definitely been like you know, the majority of freshwater work, I think, is there's definitely been some studies on lake trout. I'm not sure, you know, if there's a need necessarily, like, so, you know, if we go in and look at the literature, do like a good literature search, it may end up that we have a pretty good understanding of like what are good catch depths for those fish where they can still be released and not have issues. With these shallower species like black crappies and even bluegills, actually some of the research may indicate they may even be more sensitive than black crappies are to barotrauma. So this was kind of a place in the literature where these species were understudied. So there's a lot of great information out there. That I think there's actually a over 10-year-old study on walleyes and northern pike in Minnesota. There's plenty of research out there for lake trout. We do know a bit about them, and then also a lot of the turbine passage stuff. So this under ice fishing for panfish was kind of one of the places where we just didn't have much to go on. So that's kind of what prompted the interest in doing that work.
Yeah, and I think what I can add to that, you know, we're fortunate here in Minnesota that, you know, we've got obviously a lot of people that really enjoy the outdoors. They love fishing and they love educating themselves about fishing. And, you know, because some of the media opportunities, programs like this, I think we're able to do a better job of outreach than we used to. So what we're hearing from a lot of our anglers is that, you know, really for a variety of different species, that they're really interested in learning more about barotrauma. You know, so the more of this information that we can get out there, the more feedback we get from our anglers. And then I think that really helps kind of steer the ship as to where we should be focusing more of our efforts. You know, so it's kind of an exciting time in fisheries management to be able to do some of these projects, you know, and then be able to share the information with the public, but really have it be stakeholder driven.
Mm-hmm. Excellent. And I got to imagine it's pretty exciting to work on some of this research that a lot of people haven't done before. That's got to be fun. Sally asked, under natural conditions, and maybe say more about kind of how fish move through the season. What is the range that crappies can tolerate? I mean, how deep and how, I mean, obviously in the spring, they're really shallow, but how deep can they go?
Yeah, I guess I don't know the maximum depth, but, you know, typically as an angler, I'm typically, you know, I might find fish in 50 or 60 feet of water, but a lot of times they're suspended where they're only 25 to, you know, maybe 35 feet deep. That's a pretty common behavior that they exhibit. But we were surprised this past winter, we were actually catching crappie as deep as 50 feet. So clearly they'll go deeper than we thought.
Yeah, I mean, they're going to go where they can get to the food, right? So, which is a good segue. I know we promised we talked a little bit about some tips and techniques. We got, you know, open water across a lot of the state now, and hopefully to warm up, we'll be doing some spring crappie fishing. But we were talking earlier that crappies, they're not actually up shallow in the next few weeks to spawn because they spawn later in the spring, right?
Yep. Yeah, so, you know, essentially with the ice coming off of the lakes, those fish are going to make kind of an inshore movement looking for food. They actually started this when there was still ice on the lake. So typically with these deep water fisheries, we'll see that pattern hold together usually into February. But then as our days get longer, you've got more light that's reaching the surface of the lake. And more of that light is making its way through the snow and the ice, and it's starting to power the sediment in the shallower water. And as that sediment gets more sunlight, we're starting to see, you know, more life that's, you know, essentially occurring in that shallow water zone. Starts with the development of algae, That's fed on by our zooplankton and our microinvertebrates, some of our aquatic insect larvae. Well, that's all a great food source for fish. So as days get longer, these panfish, and both crappie and bluegill will do this, yellow perch as well. They'll typically start migrating up into these soft bottom areas of the lake that are receiving sunlight. And then kind of put the feed bags on kind of in a pre-spawn movement.
And so northern side of the lake where you've got more of a sun angle, those are the sides of the lake too that warm up a little more quicker too, right?
Yeah, for sure. And what I like to look for as these fish move into shallower water, they're in kind of a narrower band. Not a lot of water over their head, not a lot of water below them, and they're smart enough to realize that a little bit harder to escape a predator in that kind of environment. So cover becomes very important to them. So they're typically going to look for brush. They're going to look for beaver lodges. If there's a tree that's fallen into the lake, or some of that emergent vegetation, your bulrushes, there's probably still bulrush stems that are standing from the previous year. Early on, there's not a lot of new plant growth yet. So they're going to look for that leftover stuff from last year. And that's where lakeshore owners can help by, maybe leaving that fallen tree in the lake, or leaving some of that brush out there, or leaving some of those aquatic plants, because that really benefits the fish. They're not just trying to avoid other fish predators, but when they move up shallow, they're more susceptible to bird predation as well. So they've got to be mindful of what's over their head. And if they can find a hiding spot, that's where they're going to go.
Yeah, and so if you have a dock with all these old bulrushes, you can catch them right off your dock.
Oh yeah, excellent fishing spot. Yeah, it's going to be a fish magnet. Yep.
And then, the trees that you're talking about that fall in, they will persist or survive, not survive, but because they're in the water, right? Those trees, down trees, they'll be there for decades, right?
Yeah.
Essentially.
Yeah. Yeah, and
great.
there's been studies that have looked at that. We call that coarse woody debris. And kind of on the surface of those trees, there's all kinds of life that's happening there too, whether it be different kinds of algae or some of those different invertebrates that I talked about. So that's just another way that food's produced in the lake. So there's a lot of benefits to leaving that coarse woody debris in that nearshore area.
Yeah, and the waterfowl love them as a roosting location, and of course turtles in the summer. It actually is a great article in our Minnesota Conservation Volunteer about someone who wrote a story. If you haven't seen that, the latest place issue has got a really great article about that. So what would you recommend, in the next few weeks, hopefully when we get a little warmer weather and we're going to go out for target some crappies, what bait or how are you going to target those?
Yeah, well, keep in mind, crappies like warm water. Even with a couple nice warm sunny days, that water's still relatively cool. So a fish's metabolism is largely driven by water temperature. When it's cool, they're going to be operating at a little bit of slower speed than they will, say on the 4th of July when the water's 70 degrees. So that's where some of those smaller live bait techniques can really shine. A slower presentation, maybe something like a waxworm on a small jig under a bobber can be really effective. If you go up there like in the summertime when the water's warm, I like to troll jigs. I might even fish with small spinner baits where I'm reeling a heck of a lot faster. Those techniques probably aren't going to work as good in the early spring. Kind of those smaller presentations worked a little bit slower are going to be just the ticket to get those fish to bite.
Yeah, similar
flip
bobber. You're using in the winter almost, right? Some of those same techniques.
Almost wrap your head around that at ice out. Yes, you're ice fishing out of a boat essentially. Yes.
Yeah. All right. Good suggestions. Thank you.
Yeah. And the other thing to keep in mind with that time of year, you're talking about fishing in 2 to 6 feet of water. Those are the times that catch and release is completely appropriate. A lot of times those fish are concentrated. You can enjoy a day of having high catch rates, and maybe you keep a few to eat. Much more appropriate time to enjoy that style of fishing. Whereas, in that late fall, early winter period, you might want to focus more on harvest.
Great. We do have one more question, and again, if folks want to throw a few more in, we have a little bit more time. But Chris was asking, is it feasible? And I think he's financially, to do a study utilizing some sort of microchip GPS that would be implanted into a fish, and then be able to track their response and all that.
The yes and no. The technology is probably not quite there yet for something like crappie, but there are other tagging methods that we can use, and we're kind of discussing ways that we might employ one of these marking techniques, whether it be a numbered tag that essentially we stick underneath the fish's fin, very visible tag, or we have what's called pit tags, which we put just underneath the skin, and then when we pass a magnetic scanner essentially over that tag, it'll report a number. These are very good methods for doing things like population estimates, tracking studies. So we're looking into the possibility of doing something like that with crappie.
Okay, cool. So, based on what you shared with us today, I am recalling, now I'm getting pretty old, but there was some sort of a tool or encouragement decades ago where if you were fishing fish out of deep water and their swim bladder would expand, that you could actually pierce and aspirate that swim bladder so that you could release them. Obviously, From what you told us today, that's not something you want to do, but am I remembering that there was some of those tools on the market back in the day?
Yeah, the technique is called venting. It's actually been studied in more detail with some of those deep water ocean fishes.
Okay.
It's shown that in some of those species, venting seems to be a viable option that helps with fish survival. Unfortunately, we actually tried this on our first trial, and we vented 7 fish. Unfortunately, all 7 of those fish died. And I think the problem with crappie is this swim bladder. If you've ever filleted a crappie and seen this thing, the thickness of it is about like a plastic grocery bag, maybe not even quite that thick. So it's a very, very delicate organ. And I think when we pierce that, just that damage alone is probably enough that it's going to make it really tough for that fish to survive. So we tried it on a very small sample size and we didn't have good luck with it. The other thing that we remind anglers of in the state of Minnesota, venting is actually illegal.
Okay, good to know.
Yeah, and I'd like to throw in there too that like one of the venting or fizzing is sometimes what it's called. It does seem to work better with kind of these really deep water fish because if you think about a fish that needs to be able to get down 100 feet and is its swim bladder is so swelled up that it can't even get below the surface, that's a really different scenario than you have with a crappie that if it's not handled for a very long time, it's only got to get down 30 feet to get back where it's at equilibrium. That the venting may not be that helpful. And also, in the studies that they've done looking at like how long it takes for an air bladder to heal after a fish has had that pierce is that it can take up to 2 weeks for that to fully heal. So during that period of time, that fish is going to not really be able to maintain its buoyancy the way that it normally would. So with these like more shallow water fish, it's kind of like the risks probably outweigh the rewards when it comes to venting. Especially when you consider that even using the descending device, we didn't see that much of an improvement in survival, and we didn't see any improvement when it came to internal disease signs. So it's a great idea, but unfortunately, it's just not the same as marine systems. Yep.
Well, good points. Benji, let me know if we missed any questions, but I think we got most of them. But I do have one more. This looks like, Dave, especially this study and research looks like a really fun job. So, and I know you do a lot more than just that, go out fishing and catch crappies, but tell us a little bit about how you got into the field, what it takes to become a fisheries biologist or a fisheries manager.
Yeah, for me, it was growing up in kind of north central Minnesota and just having a deep love of the outdoors. And I thought, boy, this is a great place to live and work. And, started to question, well, what kind of jobs are out there that might allow me to live in the northern part of Minnesota and work outdoors. And I just kind of naturally gravitated to fisheries work. As far as what it takes to have a career in fisheries management, it largely depends on what your goals are. We have some folks that we hire just seasonally to help with like our spawn take operations and hatcheries. With those, it's primarily just somebody that has an interest in the time. But if you want to make more of a profession out of it and be like a fishery specialist, there are some coursework requirements that we have. Obviously, a pretty strong background in biological sciences, mathematics to a degree, and these days more and more some of the social science stuff. But you get your foot in the door as a fishery specialist, and then from there, the sky's kind of the limit depending on where you want to go with your career. For folks that have more of just a casual interest, there's always lots of volunteer opportunities by contacting your local area fisheries office.
Yeah, and Benji, maybe we could throw that. We have a web page that lists all the area offices. We have several all across the state. So good suggestion. It's a great opportunity to connect. And we have internships too at a lot of those offices throughout the summer for college students. So those are some options to learn more and to see if it's something you really want to do. Isaiah, did you have anything you want to add to that?
Well, I mean, my position at the DNR is a little bit special. There's only one of me per state usually. The person who basically does the fish health program for the state. There's usually one or two. In Wisconsin, there's two. There's one here. But my pathway is much more of one where I was interested in research. I was interested in fish health, microbiology, and pathology. So I wouldn't recommend mine necessarily. I loved my career, but it had a lot of years of basically being a graduate student and making ends meet that way. But the goal was always to do something where I was working in conservation, wildlife, health management.
Great. And you have your doctoral degree, I see. So
if you're interested in something like that, just stick with it.
Yeah. We did have one more question come in about some of the research, and then John is asking, is there anything in the literature that shows that crappie hunt throughout the water column when at depth, and will they move throughout the water to find prey and cause their own barotrauma? They're chasing, I guess, or something.
Let me just say that seems unlikely. We don't know for sure, but I'll throw an interesting factoid out there, which is that in cetaceans like whales and things like that, and some of the skeletons that they've been able to like save for research purposes, they actually have identified signs of barotrauma even in these like cetaceans that are basically mammals that take air from the surface and they go deep and they go back up to the surface to get food, and they do have some signs of barotrauma, but they're able to essentially deal with it. Now, total opposite end of the spectrum, you have something like a crappie. They're making some physiological sort of like changes when they're moving throughout the water column, and then when they ultimately decide to chase a fish. And they have really interesting specialized structures inside of their swim bladders that lets them absorb gases from inside of that swim bladder really rapidly. It's a really cool, physiological adaptation that these fish have, where they're able to do that. So there may be some choice involved in when they're actually under their own power pursuing prey or deciding where they're gonna be in the water column, that basically just makes them able to do that, to make those changes. But when when a fish is being caught and pulled up from depth, it's being rapidly disoriented, and so it's maybe not a very fair comparison. So I would say that it's probably unlikely that they're killing themselves with barotrauma when they're chasing a minnow through the water column and they're meaning to do something like that, versus when they're hooked and then they really don't have any choice and they're pulled up.
Well, evolution. Go ahead, Dave.
We saw that to a degree with the net pens when we lifted those up too. And again, we were kind of bringing those nets up slowly. But those fish could handle quite a range of depth change. And it seemed like the fish that had recovered stayed recovered until we got to a certain point. A lot of times it was within 10 feet of the surface. And then they all showed trouble kind of at the same point. So yeah, I think there's a range, and the fish can certainly sense that and knows where its comfort zone is, where they can move up and down and be just fine. But when we're, as anglers, kind of taking that choice away from them and bringing them all the way up near the surface, that's more than they can handle.
Yeah, and they wouldn't last very long as a species evolutionarily if they didn't stay within the limits of their physiological ability. So
Yeah.
thanks for all the great questions, everybody. Thanks for the information, Dave and Isaiah. It was really fascinating and really good. Glad you could have this here with us today. We're almost out of time, but I do want to let folks know, please check out the recording if you want to do that at mndnr.gov/discover. That'll be up in a few days. And like I said, all of the previous 156 episodes are there. So please check those out. If you found stuff interesting today, we've got a lot of similar programs up there. And then next week, we're going to have our bear research specialist, Andy Try, will be back to tell us about some really fascinating research he's been doing about bears and what we know about the population in Minnesota and how old bears fare on in our state. And then 2 weeks from now, back to some fisheries folks that have been working on climate change and the impact that has on our fisheries and some of our, especially our cold water fisheries. So especially seeing this winter and spring that we've had, it'll be interesting to hear more about how we're seeing some changes in Minnesota fisheries from our climate change. So thanks again for being here, guys. Really appreciate it. And thanks everybody for joining us. Hope to see you soon.